So before anything else, let me introduce to the topical workbook for computer science 2210 or 0478. This is the workbook 1 for paper 1, basically computer systems. And as you can see from the table of contents, I've included questions on each and every subtopic from the syllabus along with the mark scheme. And these are some of the actual questions, actual pages as a preview from the workbook. Section 1.1, 1.3, 2.2, 3.2, 5.3 cybersecurity and artificial intelligence. This is just to show you a glimpse of what type of questions are included in the workbook. There are many more questions where these come from, and around 18 to 20 questions on an average are included for each and every topic. A must buy if you want to boost your grade. Similar to the paper 1 workbook, I have designed a paper workbook for paper 2 as well. This is for algorithm, programming and logic for CIEs either 2210 or 0478 GCE or IGCSE Computer Science. As you can see, it contains questions on every subsection of the syllabus content for paper 2 along with the mark scheme, so you can understand each and every question, each and every algorithm. These are some of the few pages from the workbook just to give you a glimpse of what type of questions are included. As you can see, this is 7.1, this is 7.7, 8.3 and section 10 Boolean logic. So a lot more questions are included in the workbook. A must buy if you want to have a very good score in your Cambridge examination. Order now. Assalamu alaikum warahmatullahi wabarakatuh. Welcome to another physics lecture. So today we are going to start section number 2 of the new syllabus for physics, that is thermal physics. Section 2.1 is supposed to be the kinetic particle model of matter. Now the first thing you need to know is that there are 3 states of matter, as you would have studied in chemistry and basic sciences as well, and they are supposed to be solid, liquid and gas. And in physics we have to basically consider the arrangement of atoms in these 3 states of matter. So in solids, solids have very strong atomic bondings and high viscosity, hence they have high density, they are incompressible, you cannot compress them, and they have a definite shape or an inflexible shape. The atoms in a solid are closely packed together and occupy minimum space in a regular pattern most of the time. It's not always necessary, but most of the time atoms in solids have a regular shape. Due to strong forces, motion is limited to random vibrations of particles about their closely packed location. This is the arrangement of atoms in a solid. When you provide heat to it, when they gain energy, then these particles vibrate at their fixed position in form of a solid. They do not unless and until you provide too much energy and they melt away or they change into a liquid. As long as they are a solid, they keep on vibrating at their fixed place. They are not able to move. Liquids have a definite volume but no fixed shape. The particles of a liquid are arranged in small clusters and condensed like those of a solid. These particles vibrate randomly near their main position, but they have a low viscosity, and cluster form enables them to change shape. When a liquid is poured into a container, it takes the shape of the container. The strong attractive forces between particles are responsible for limiting the liquid particles near the surface of liquid from escaping. So this is the arrangement of molecules in a liquid. The molecules are clustered together, but they do have free space among them. They do have some distance between them. hence the liquids are able to be poured, and liquids are able to flow, and liquids do not have a definite shape. Next we have gases. A gas has no definite volume or shape. Gases consist of weakly bonded particles with no structure or long range periodicity, and they move vigorously and randomly at high speed. The gases usually expand to fill any available space. The particles in gases are far apart and have negligible attractive or repulsive forces, and therefore are easily compressible. Now, if we have to compare the three states, solid have a definite volume, liquid have a definite volume, gas has no fixed volume. Solid have a definite shape, liquid have a definite shape, but gas does not have a definite shape. Compressibility: solids are not compressible, liquids are not compressible, but gases are compressible. Density is usually for solids very high, for liquids it is high, not too high, and for gas it is the lowest. Forces between atoms: solids have very strong intermolecular forces, liquids have strong forces, whereas gas particles have very weak intermolecular forces. Moment of atoms: in solids they can only vibrate at their fixed position. In liquids they are able to move past each other, but they have limited movement, not indefinite or unlimited moments. In gas, particles have random movement independent of each other and at high speed. Energy of particles: so in solids they have very low energy, in liquids they have greater energy, and in gases they have very high energy. Whereas when we talk about arrangement of atoms or molecules, in solids they are closely packed together, in liquid they are closely packed in clusters, in gas they are very far apart and occupy any given space. They have negligible force of attraction between them. Example question: a teacher shows a class examples of three states of matter. These are solid metal block resting on a bench, a liquid in a glass beaker, and a gas in a clear balloon in the laboratory. 4.1a represents the arrangement of molecules in a solid over here. Now 4.1b and c for liquid and gases are empty. Complete 4.1b to show the arrangement of molecules in liquid. They should be in random order, and they should have some distance apart, like 2 molecules here, 2 molecules here, 3 here, 3 here, 3 here, and 3 here. They should have a little bit of space between them and not to be closely packed like this. In complete 4.1c to show the arrangement in gas, then for a gas the position should be extremely random. The particles should be very far away from each other. One particle over here, one over here, one over here, one over here, one over here at random positions. In the list below, draw a ring around the state of matter that is easiest to compress: solid, liquid, gas. Then that would be the gas. In terms of its molecule, explain why this state of matter is easiest to compare. Because this state of matter means the gas have a lot of free space between the molecules that can be compressed. And gas molecules also have weak forces of attraction or repulsion between them, so it is easy for them to be compressed. It is of 2 marks, so we state 2 points. Now once we have studied about the states of matter, we next study about the change in state of matter. When a substance changes state, the number of molecules in that substance doesn't change, and neither does its mass. The only thing that changes is its energy. Change of state are physical changes, and so they are reversible. This is a curve for change in state. Below 0 degree centigrade, this is for ice. For different objects it can be different, as this is for water. So below 0 degree centigrade, water is in form of a solid, means ice. At 0 degree centigrade, it starts to to melt, and once it has fully melted, it becomes a liquid, and then it keeps on gaining energy as the temperature rises. Once it reaches 100 degrees centigrade, then it starts to boil and turn into a vapor, gaseous form, into steam. Once the water has fully turned into steam, it moves away in form of a gas, and if further heat is provided, all of the liquid would be converted into gaseous form. Example question: what increases when a liquid becomes a gas at its boiling point? The average kinetic energy of the molecules, the molecule size, the molecular spacing, the total number of molecules. C would be the right answer, because when a liquid becomes a gas, the space between the molecules increases. A block of ice is taken from freezer at -25 degrees centigrade, placed in a metal container and heated by a source of constant power. The graph shows how the temperature of container changes with time. At point E on the graph, the container is empty. This is the graph. It starts at -25 degrees centigrade, and then it goes on and then on. State what is taking place in the regions of graph from B to C and from D to E. Whenever we have a straight line in a temperature time graph, it means a change of state is taking place. So from B to C at 0 degree centigrade, a change of state is taking place, which is ice is turning into liquid, or we say ice is melting. And from D to E, another change is taking place, as this is 100 degree centigrade. So we say that water is turning into steam. Melting and freezing. Melting occurs when a solid turns into a liquid. For example, ice turns into water. And freezing occurs when a solid turns into when a liquid turns into a solid. For example, ice freezes up, water freezes up in form of ice. Boiling and condensing. Boiling occurs when a liquid turns into gas, whereas this is sometimes also known as evaporating. Whereas condensing occurs when a gas turns into a liquid. This curve is reversible. Sometimes we have steam which cools down and turns into liquid, and then it further cools down and turns into a solid. Temperature and kinetic energy. When temperature of a solid is increased, kinetic energy is supplied to the particles and they start to vibrate more rapidly. On the other hand, when temperature is reduced, the average kinetic energy of particles reduces, and eventually a temperature is reached where particles stop moving at all and the kinetic energy of particles is zero. This temperature is known as absolute zero or absolute temperature, and it occurs at -273 degrees centigrade. We also call it as 0 Kelvin. The temperature in Kelvin or absolute degree is supposed to be written in T. The formula is T equals to theta. Theta is supposed to be in Celsius, plus 273 degrees. This is the formula to convert to find Celsius into Kelvin. Kelvin equals to the value in centigrade plus 273, where if you have to convert Kelvin into Celsius, then simply minus the Kelvin value with 273. This is the formula for that. Remember these two formulas for conversion: T equals to theta plus 273 and theta equals to T minus 273. This is a graph. Normally we have this shape of a graph for an object, and when we extrapolate it, a volume versus temperature, then a time comes when the volume of an object virtually becomes zero, and that occurs when we are at minus 273 degrees centigrade, which is known as 0 Kelvin, or absolute temperature. This is a volume temperature graph for a gas. Now remember one thing, at this point in a change of state curve, in a heating or cooling curve, this is also known as a heating or a cooling curve, at this point energy is being constantly supplied but the temperature is not increasing. This happens because the energy being provided, the heat being provided, is used to break the bonds between molecules and change the state. Similarly, at this point where boiling is occurring, no temperature change is taking place. Why? Because all the heat that is being provided is being utilized to break away the bonds and convert liquid into a gas. Hence the overall temperature is not increasing. Whereas when we are having a cooling curve, then the energy is being taken away and it is being lost to the surrounding. Hence the molecules are coming closer together. Thus no you can say no temperature drop occurs. Once all of the steam has condensed into a liquid, then the temperature starts to drop. Similarly, when the liquid is converting into solid, the energy being given away by the molecules is being lost to the environment as they come close together and arrange themselves in a crystalline lattice. Once all of the atoms has lost their energy and they have closely packed themselves together, only then the temperature would start to decrease any further. Okay, so that's it for today. I hope you have understood everything. If you have any problems, feel free to comment them below. Take care, and I'll see you guys in the next lecture. Allah Hafiz.